Hello, I'm Dr. Larry Goldstein, Chief Technology Officer for Honeywell Sensing and Control. Today I'm here to discuss electromechanical switch technology and Honeywell's MicroSwitch basic switch products. First of all, what is a switch? A switch is an electromechanical device used in contact applications where the switch is actuated by touching an object or target. The actuation of the switch typically causes an on or off action. Each switch contains a spring and a set of contacts that convert mechanical energy applied to an actuator into an electrical output. Switches come in many styles, such as basic, rocker, and toggle, and also in various shapes and sizes, such as subminiature and V-basic. To determine the right solution, you'll need to confirm the function the switch will perform. Clearly understanding the difference between switch types, their characteristics, and expected performance is important to your product's success. So how does a switch work? This shows the inside of a switch. With the plunger in the released or free position, the common contact is against the normally closed contact. In this condition, the normally closed circuit of the switch can carry current. This means there is electrical continuity between the common terminal and the normally closed terminal. The common terminal is electrically insulated from the normally open terminal. As the plunger is depressed, it reaches the operating point. The distance between the free position and the operating point is called the pre-travel. At the operating point, without further movement of the plunger, the common contact accelerates away from the normally closed contact. Within a few milliseconds, the common contact strikes, bounces, and comes to rest against the normally open contact. Because the mechanism is designed for snap action, the common contact cannot stop part of the way between the normally closed and normally open contacts. The normally closed circuit is now open, and the normally open circuit is closed. As the plunger is depressed past the operating point, the normally open circuit remains closed, and the normally closed circuit remains open. When designing an electromechanical switch into an application, there are 7 design factors to consider: the requirements for load, the life of the switch's operating environment, how the switch will be actuated, the switch's size, how it will be mounted, and finally, how it will be terminated. Electromechanical switches can be found in many of the things we use every day, like dishwashers, microwave ovens, and elevators, and other applications we don't often think about, like residential furnaces, industrial boilers, jetways, cockpit control panels, and the space shuttle. Now let's go back 75 years and talk about the history of MicroSwitch technology. In 1932, Dr. Charles Burgess of Burgess Laboratories assigned one of his mechanics, Peter McGall, to develop a switch to control the temperature of a chicken brooder. This led to the development of the first MicroSwitch precision snap-action basic switch, which was quickly adapted for other applications. In 1937, the electronics division of the company was spun off and became the MicroSwitch Corporation. That company was acquired by Honeywell in 1950. Honeywell then developed a number of products based on the technology, like explosion-proof switches, limit switches, switches for industrial machine safety, and switches for aerospace applications. Today, Honeywell manufactures more than 120 million MicroSwitch components annually. Honeywell offers a broad portfolio of MicroSwitch basic switches, including both premium and standard versions of V-basic, large basic, miniature, and subminiature products. Honeywell's premium switches are designed for precision applications where the cost of failure is high and accuracy and repeatability are critical. Premium switch applications also frequently require sensitive actuation with low operating force. Honeywell standard switches are designed with the same high quality as our premium switches, but for applications where the cost of failure is low. It is important to choose the right kind of switch for the requirements of the application. There are 5 things you should consider when choosing a MicroSwitch basic switch. Application. What size do you need? Does the switch need to be hermetically or environmentally sealed? Does the application require a premium or standard switch? Repeatability. The switch should actuate and release within a specified tolerance band every time. Of course, a switch with repeatability of 1 million cycles will cost more than one with only 50,000 cycles. Reliability. How many cycles of reliable switch operation does your application need? For example, a superior switch can operate for 10 million cycles before mechanical failure and 100,000 cycles under maximum load before electrical failure. Smooth actuation. A switch should be easy and smooth to actuate with a short travel. It should have a repeatable snap action feel and sound. It should not stick, bind, wobble, or change travel characteristics even after 10 million actuations. Quality. The price difference between a high-quality switch and a mediocre one is usually just a few cents. Think of the total life cycle cost, including the cost of failure, not just the cost of the component. Don't expect a commodity switch to perform like a premium one. How do Honeywell's MicroSwitch basic switches stack up against the competition? We invented MicroSwitch technology and have the most experience in its application. Our switches have been used in industrial equipment for more than 30 years, in process industries for more than 40 years, and on airplanes for more than 50 years. Our premium basic switches have higher accuracy, repeatability, and reliability than competitive products. We have a variety of packaging options, like explosion-proof, hermetically or environmentally sealed housings. We offer the broadest portfolio in the industry, with both premium and standard products to meet our customers' needs. Some specific aerospace and industrial applications using Honeywell MicroSwitch technology are in commercial aircraft. Our HE and HM sealed switches are frequently used to indicate if the landing gear is up or down. Toggle switches are found in cockpits worldwide. Honeywell's newest 1HP and 1MP series pressure switches are frequently used for hydraulic pressure sensing. And the HM series sealed basic switch is used to indicate that aircraft doors are closed. Some industrial applications include boiler and damper control in HVAC systems using our large basic and sub-miniature premium switches. Valve position detection in oil and gas refineries, waste treatment plants, and other factories using our basic switches, and pressure release valves and air compressors using our premium basic switches. So what should you remember about Honeywell's MicroSwitch basic switches? Honeywell offers the largest portfolio of premium and standard switches that operate over a wide range of environmental conditions. Honeywell's MicroSwitch snap-action switches are reliable, durable, and accurate. Honeywell manufactures globally, and our switches have broad international certifications. Because of this, we can deliver products to you quickly and efficiently anywhere in the world. Honeywell owns the original MicroSwitch technology and provides optimized packaging for thousands of applications. With over 75 years of experience in applying this technology, we can help you find the best switch solution for your product. For more information about Honeywell's MicroSwitch basic switches, send me an email at dr.larry@honeywell.com or visit our website at honeywell.com/sensing. Thank you.